Hello students, the purpose of this video is to get you comfortable thinking about even and odd functions, and we're going to talk about this from a graphical approach first, and then we'll go from an algebraic approach. The graph of an even function is symmetric with respect to the y-axis. So the things that you want to remember is that if I'm dealing with an even function, I will be symmetric to the y-axis. If I'm dealing with an odd function, I'm going to be symmetric with respect to the origin. There's no great way to remember this, but what I always tell individuals is if you can remember that odd starts with an O and origin starts with an O, those are the two that go together, so y-axis has to be with the even functions. So if I look at this particular function, you see that I have identified it as an even function, but why? Well, even says that I am symmetric to the y-axis. So if I go on my graph and I am going to highlight my y-axis, and I imagine folding this graph on this purple line, both sides of my function, the right and the left, would lay on top of one another perfectly, and therefore that shows symmetry. Looking at this function, you can see that I've identified it as an odd function, which means I am symmetric to the origin. And you could draw the origin going this direction, which would actually be on the function. I can also draw it the other direction. Either way, when I fold this graph on one of these dotted lines, the function is going to appear on itself, and therefore it is odd. Now you'll notice I've identified neither for this specific function because it only appears in quadrant 1. And so if I fold this graph on my y-axis, the graph is not going to be on top of itself at all. There's nothing else for it to match with. Same thing if I were to do my origin, there would be nothing for that graph to touch with. Now, if I had something, and this is a rough sketch, not accurate, but, something that looked like that, okay, then, we could possibly have some symmetry because I would have both sides of the graph on the left and on the right. But since I'm only appearing in quadrant 1, there's no way for me to fold this graph in order for it to be symmetric. All right, so now how do we go to an algebraic approach? Well, step 1 is to plug in the value negative x for every x that you see. So you're literally going to evaluate negative x. If you get exactly the same answer back, it is even. But if you get the opposite, so it has to be an exact opposite, which means everything changes, but you get an opposite, then your function is odd. And then if some parts change while others stay the same, it is neither. So I always remember exactly the same. It starts with an E, and so exactly the same is even. And then opposite, and I want to make sure I remember everything changes. But if I have an opposite equation, then it is odd. So the E's match up and the odds match up. And if I have some combination, then it can't be either one. So looking at number 1, f of x is equal to x to the third power minus x. I'm going to take that function. I'm going to evaluate at negative x. So x cubed minus x, and in for x, I'm going to plug in negative x. And negative x to the third power is still negative x, and the negative and a negative change to a positive x. So when I compare this answer here that I've boxed in green, I notice my first term was a negative and now it is a positive, so that changed. And I noticed the second term was a positive, or started out as a negative, and it's now a positive, so that changed as well. So it is exactly the opposite signs. Therefore, this is an odd function. When I look at my second example, and I want to evaluate at negative x, I have x squared plus 1, and in for x, I'm going to plug in negative x. Well, that's going to make a positive x squared plus 1. So it started out as a positive, it started out as it ends as a positive, so that's the same. It started out as a positive, ended as a positive, so that's the same. If I'm the exact equation, then I am even. And now my very last example, I'm going to evaluate again at negative x, and I have x to the third minus 1. And in for x, I'm plugging in negative x. So that's going to give me negative x cubed minus 1. I started out positive, I ended as negative, so that changed. I started out as negative, I ended as negative, so that's the same. Since I have a combination of some things changing and the others not, this would be neither even or odd. As always, I hope you found this video helpful. Remember, there's extra resources. If you need them, feel free to reach out to me as well. I'm happy to assist. Otherwise, I hope you have a wonderful rest of your day.